Okay, everybody. Hope you're having a nice break. Melissa asked me about, I think it was sections, problems 3 and 4 on the inclined plane friction problem. So I made up a problem that's similar to number 3, and I'm going to do it here, and maybe that will help you. The thing about these problems that's kind of weird is that the way we do them is we make x in this direction and y in this direction. So we sort of turn our whole frame of reference as if the plane that it's on is horizontal. But in reality, we've got an mg coming down like this. We've got a normal going up like this. Here's our applied. And then we've got a friction going against the applied like this. So it turns out if you look at it carefully, we're going to take this mg and we're going to break it into two pieces like this. And so part of it is going down into the inclined plane and part of it is going across the plane. And this angle is that same 35 degrees. What that means is that it's different than our normal situations. mg sub x is actually mg sine 35 because it's opposite the angle. And mg sub y is mg cosine 35 because it's the adjacent. So let's look at the forces in the y direction. The sum of the forces in the y direction, we've got the normal going up, F sub n, and then we've got this mgy going down, mg cosine 35. And since it's not jumping off the inclined plane, those are equal to 0. That means that F normal equals mg cosine 35. In our case, that's going to be, let me bring up my calculator. M is 4 times 9.8 times cosine of 35. So that's 32. So that's 32 newtons. That's what Fn is. 32 newtons. That's going to be important because that's what we use to calculate the friction, because remember that we have two possible situations. If it's not moving, if a sub x equals 0, then we use the static friction. Then the friction force is less than or equal to mu sub s times the normal force. That's less than or equal to 0.5 times 32, which is 16 newtons. If a sub x is not equal to 0, if it's moving, then, then the frictional force is equal to the kinetic coefficient of friction, mu sub k Fn. So that's equal to 0.1 times 32. is 3.2 newtons. So we have to figure out whether or not there's enough friction to keep it from moving. Because if there's enough friction to keep it from moving, then the acceleration is 0. But if there's not enough friction to keep it from moving, then we have to figure out what the friction force is and then what the acceleration is going to be. So let's look at the sum of the forces in the x direction. Why don't we make to the left positive, because that's kind of the direction we're pushing it. I know it's sort of counterintuitive, but I'm going to call that positive. So the forces in the x direction are 50 minus the friction force minus this one here, mg sine 35. Okay, so let's assume if a sub x equals 0, use, if a sub x equals 0, okay, then all this equals 0. So that means 50 minus ff minus mg sine 35 equals ma, right? That's 4 times 0. Okay, so we can calculate 50 minus mg sine theta. minus 4 times 9.8 times sine 35, that's 27.5, right? 50 minus m times g times sine 35. That would be all the x forces. And then, so basically we have 27.5. Let's see, so that's 27.5 minus the friction force equals 0. So the friction force equals 27.5. But what is the maximum friction force? Well, we're told right here that the maximum that the friction force, if it's not moving, is less than or equal to 16 newtons, right? So that means that this is not true, right? That's more than 16 newtons. So therefore, this implies that a sub x is not equal to 0. So that means that instead of this equation here, we have to have, hold on just a minute, we have to have the sum of the forces in the x direction is going to be 50, because that's the force applied. Okay, and then we've got minus f sub f. But what is f sub f? Well, we figured out that that's 3.2, right? Because that's the friction force based on the normal force if it is moving, if a sub x is not 0. Minus 3.2, okay, minus mg sine 35 minus 4 times 9.8 times sine 35, and that has to equal ma, 4a. So therefore, a equals 50 minus 3.2 minus 4 times 9.8 times sine 35 divided by 4. So let's find out what that is. Okay, I'm going to put an open parentheses. 50 minus 3.2 minus 4 times 9.8 times sine 35. Close that, and then another closed parenthesis, so they've got all that together for the numerator, divided by 4. And it looks like we have 6 meters per second squared. And it's going to be to the left. So that's the acceleration. So I'm putting this up on YouTube so you can look at it, you can slow it down, you can pause it, and it should help you solve these problems. All right, let me see if I can stop this thing. See you on Monday.